Hello guys, and welcome to day 3 of vibeOps Saturday. So in today's video, we are going to see how to build an IGP domain. So these routers have point-to-point connectivity. We need to dynamically learn all the neighbors within the IGP domain. So in today's lesson, what you are going to do today is that you are going to configure loopback. You're going to configure OSPF to build the IGP domain. Now, already, these devices have their point-to-point IP addresses configured. So far, we've not done any manual configuration apart from the management interfaces. So we are good to go. So now let's go to my MCP client as I have over here. So my prompt is that please configure a loopback on all these routers within the range of 192.168.254.0/24. Then enable OSPF on these routers to form an IGP domain and set the loopbacks as the router ID for this configuration. So that's all. It's going to take a while to complete the configuration. So I'm going to initiate the prompt to do the configuration, and the MCP server is going to handle everything. And then when we are done, we will go through the verification checks. So I'll also ask it to do pre and post check validations. So basically, that's a test for the prompt that I'm giving the MCP client to configure the devices. I'm going to go ahead and issue the command, and it's going to run and connect to the devices and perform the configuration. So let's see how it goes. Let me see the initial connection. So as you can see, it's trying to connect to the devices and do the configuration. It's performing the pre-check validation. And as you can see, we have the pre-check validation over here. Basically, I'm sure it's going to do connectivity check. So I'll keep the video on, or I'll pause the video and come back when the video is done. So as you can see, the pre-check validation is telling us that there is no OSPF configuration on any router. So it's going to go ahead and configure the loopbacks and then go ahead and configure the OSPF for us. Okay, so now the configurations are done. We need to go through the configurations and how the MCP client was able to do the to calling, the function calling to get the devices configured. So along the line, I had an outage on my internet, so I had to issue the command. So in some part of the configuration, you're going to realize that it's going to detect that I think in the process of doing the configuration of some of the devices we went offline, and then it had to detect that using the pre-check validation and reconfigure the unconfigured devices. So the first thing you're going to look at is the pre-check validation. You're going to see the commands that the MCP client actually executed on the devices. So look at the Junus command. So it's checking for OSPF neighbors basically as a pre-check validation. But then the response is that so the Juniper had the neighbor. This was not configured by me, but rather it was configured previously before I had the outage on my connectivity. So it noticed that it has an OSPF neighbor. That's fine. Now let's check the next one. So the next one is show IP OSPF neighbors. So this is on the Cisco router, and it could see that it has neighbors as well. So the response is true. Now we check the next one. It should be the MikroTik, and as you can see, the MikroTik had no OSPF configuration. So basically, during the configuration, I think after the Cisco, the MikroTiks had no configuration because of the outage that I had. I had an outage, so I think it affected the devices as well. Now let me check this one well. So this one had an OSPF instance configured. So that is CSR 1004. So I think that's all for the pre-check validation. And let's see the OSPF. So basically so this is for the loopback interfaces. And as you can see, it had a loopback configured for the Juniper. And now for show IP interface view, this is for the Cisco. It had a loopback configured. This would be for the MikroTik. Yes, it had a loopback configured. So you can check the other one. This one had, okay, this one too has a loopback configured on it. So let's see which one is this. So it's looking for the loopback configuration. Yes, so it has it. And so this assigns the IP address to the loopback on the CSR 1000. Sorry, the that core router, 104 vibeOps. So this was basically to check the loopback interfaces. And now see the response. Good. The loopbacks are already configured. Let me verify the OSPF configuration. We can check that from the Juniper. And as you can see, it's checking the configuration for OSPF. And there we have it. And then we have for the Cisco as well. So this is the Juniper again. So looking for the router ID. So let's see for the Cisco, it had the configuration for OSPF. And now this is the MikroTik. So it had no configuration for OSPF. So I think it had to reconfigure the OSPF again. So let's see for this one. And as you can see, it detected that there is no OSPF configuration. So as you can see, the next line is configure CSCC Cloud Core Router 2004 needs OSPF configuration. Let me configure it. So it did the OSPF configuration over there. So that's for the Cloud Core Router, adding the various OSPF parameters that we are going to need to establish a neighbor. And as you can see, now it's been able to configure the OSPF parameters for the Cloud Core Router 2004. And now checking for 1001, that's a MikroTik router. I think it had the configurations already there. So there's no need for additional configuration over here. So that was for the Cloud Core routers. I think I haven't seen the Juniper so far, right? So let me see this one, maybe this one. Okay, so this is still working on the Cloud Core 1004. Wait a moment for OSPF to form, the neighbors to form. So let me see what it had over here. So, okay, so it executed a sleep timer of 15 seconds just to wait for the OSPF to converge. And this is very, very intelligent from the MCP client. It's able to wait for like a couple of times, just like we configure these protocols, then we just sit back and wait if they're going to have MTU issues or MTU mismatch issues or any misconfiguration that is going to prevent the neighbor from coming up. That's brilliant. So we see the post check validation over here. So basically to check OSPF neighbors. So this is the Juniper, and then we have the Cisco. No, I think this is the Juniper as well. And then we have another one for the Juniper. I think it's executing various commands for the Juniper, which is very intelligent. So this is the Cisco side as well. And this one is the MikroTik side as well. And you see how intelligently the MCP client is able to use the MCP servers to configure the devices. Once again, none of these commands were executed manually. Everything was done by the MCP service. So this is next level automation. So you can simulate your labs or your production network in a digital twin fashion, do all your pre-check, post-validation, configuration checks, and before you move it to production. I've done it in production and it worked for me because I had to simulate the digital twin of a very complex Cisco router. So I did it on an MX204 using the Juniper MCP server, and everything worked well. So that's something that I mean we can all use so I think the rest are basically the verification checks. So we have a document over here which we can go through over here. So basically OSPF deployment validation report, and the date is 27th of February 2026. So we have the summary over here. It's been able to configure everything, the pre-check validation, loopbacks configured, everything is fine. The configurations that we did for the post validation as well. We can see everything over here. I'm going to include this in my resources for this particular video. And as you can see, you see, this is very intelligent. It's giving you more insight. So let's imagine that you are a new engineer, don't even know how your network is structured, but you're able to simulate this digital twin. It's going to tell you like how the OSPF cost, and as you can see, we didn't configure any OSPF cost. So it's basically detecting ECMP across the multiple paths that the devices have. And this is very, very intelligent because it helps you to understand how the whole IGP domain is being designed. And as you can see, we have a very nice summary over here. So validated by Claude MCP automation report generated today, this morning. So thank you for watching this video. And in my next video, I don't know, we're going to try a different routing IGP domain, right? I'm going to configure ISIs on these routers as well. Thank you for watching this video and make sure you join me on my next video. Bye-bye.